More than 90% of everything we see in the universe, from clouds and planets to ourselves, is made of the dust of dead stars. They are not just sources of light in the night sky. They are the magnificent factories of existence that create the fundamental elements of life. But how are these massive, burning giants born? How do they live, and how do they eventually meet their end? In this documentary, we will take a journey into the world of stars, from their spectacular birth to their mysterious death, and especially the sun, the star that has given meaning to our lives. The birth of a star begins with something that at first glance seems insignificant, a massive, cold, and dark cloud of gas and dust called a nebula. These nebulae, also known as stellar nurseries, can span thousands of light years. Within these immense masses, gravity slowly pulls particles towards each other. Over millions of years, this gas and dust become more compressed and dense, to the point that the temperature and pressure in its core rise dramatically, forming a protostar. This protostar is a hot, glowing ball of gas, but it is not yet a true star. It is at this moment, when the core's temperature reaches more than 15 million degrees Celsius, that the pressure and heat become so intense that hydrogen atoms fuse together to form helium. This process, known as nuclear fusion, releases a tremendous amount of energy. This immense energy counteracts the force of gravity, keeping the star stable. With the onset of fusion, the protostar transforms into a true star, radiating its light and heat into space. Every star, depending on the mass it has at birth, follows a different path throughout its life. This path also determines its ultimate fate. Small to medium-sized stars like the Sun, main sequence phase. Stars like our Sun spend the majority of their lives, about 90%, in this phase. During this time, the star burns hydrogen in its core, maintaining a stable balance between the force of gravity, which wants to crush it inward, and the outward pressure from fusion, which wants to make it explode. Red giant. When the star's core runs out of hydrogen fuel, the core begins to contract and heat up. This heat causes the outer layers of the star to expand dramatically, and the star becomes a red giant. In this phase, our Sun will grow so large that it will engulf the planets Mercury and Venus and likely turn Earth into a scorched, uninhabitable planet, giant. In this phase, our Sun will grow so large that it will engulf the planets Mercury and Venus and likely turn Earth into a scorched, uninhabitable planet. Planetary nebula and white dwarf. After the red giant phase, the star's outer layers are gently expelled into space, creating a beautiful, glowing cloud of gas called a planetary nebula. This nebula has nothing to do with planets, it is merely a historical misnomer. At the center of this cloud, the star's hot, dense core remains, known as a white dwarf. This tiny, compact object will slowly cool and dim over billions of years, eventually becoming a black dwarf. Massive stars, red supergiant and supernova, stars with more than 10 times the mass of the Sun have shorter, more energetic lives. After exhausting their hydrogen fuel, they become red supergiants and their cores begin to fuse heavier elements like carbon, oxygen, and even iron. When the core reaches iron, fusion stops and the force of gravity causes the core to suddenly collapse. This catastrophic collapse triggers a massive and brilliant supernova explosion in which all of the star's material is blasted into space. Neutron star and black hole. Following this explosion, the remnant of the core can have two possible fates. Neutron star. If the remaining core has a small enough mass, it collapses into an incredibly dense neutron star. Black hole. If the core's mass is very large, gravity becomes so strong that it crushes all of the material into an infinitely dense point. This point creates a black hole, where not even light can escape its gravitational pull. The Sun, the heart of the solar system. The Sun is a yellow dwarf star and is in the middle of its life. It is approximately 4.6 billion years old, and it is expected to continue shining as it does for another 5 billion years. The Sun's layers. The Sun is composed of several layers, each with unique characteristics. The core, at the center of the Sun, where temperatures reach 15 million degrees Celsius and nuclear fusion takes place. The energy produced in this layer makes life on Earth possible. The radiative zone. The energy produced in the core travels through this layer as radiation. A single photon of light can bounce around for thousands of years before finally escaping. The convective zone. In this layer, plasma and hot bubbles rises to the surface and, after cooling, sinks back down to transfer heat. This process creates a boiling appearance on the Sun's surface. The photosphere. This is the visible surface of the Sun that emits light and heat. Its temperature is around 5,500 degrees Celsius. Sunspots, which are cooler and darker regions, appear on this layer and are signs of intense magnetic activity. The chromosphere and corona. These are the outer layers of the Sun's atmosphere. Astonishingly, they are much hotter than the surface. The temperature of the corona can exceed 1 million degrees Celsius. Solar flares and coronal mass ejections (CMS), which can impact Earth's space weather, originate from these layers. This magnificent spectacle of the birth, life, and death of stars is the amazing story of our own existence. Every particle of our being shows our inseparable connection to these massive cosmic factories. If you enjoyed this cosmic journey, don't forget to hit that like button. And for more journeys into the world of science, subscribe so you don't miss any videos.